right, so we have here an example problem. We have an object being pushed by a variable force. We can see that in the figure. They're graphing force versus position. So we are assuming this force is just acting in the x direction because it's not the problem isn't giving us any indication otherwise. Now remember, we have the basic equation for work is the integral of the force dotted with the displacement. The dot product, again, multiplies parallel components. So ultimately, we can say in this specific problem, the work can be calculated by integrating this force function with respect to x, because it's telling us the force is plotted versus x, the horizontal position. So this is specifically the equation we can apply. Now, technically, we can write the function for f, determine what it is, or if we remember the integral is the area under the curve, we can look at the area. So, for example, in this first portion, from here to here, so again, this is the x-axis. In this first portion, the area would be 1/2 base, which is what, the 6, 5, 4, 3, 2, so 2 meters times height. This tells us that we, 2 newtons times meters, which is a joule. So step 1 is 2 joules. Step 2 continues going down. So this second section, 1/2, its base is 2 meters as well, but the force, the height, is -2. So we get -2 Newton meters. So we're adding the work in section 1 plus the work in section 2, which now has added to be 0. That positive work is canceled out by the negative work. The last section is this rectangle in here. Since it's a rectangle, we only need the base times the height. So 2 joules. When we've added everything together, the result is 2 joules. So as this object moves between x of 0 meters to x of 6 meters, the total work done is 2 joules. If the problem could easily ask how much work was done from x equals 0 to x equals 2 meters. That answer would be positive 2 joules as well. If the problem asks from x equals 2 meters to x equals 4 meters, the answer would be negative 2 joules, meaning energy was being removed from the system. So we just need to look in the region designated by those 2 locations. If we have a function, we'll totally integrate. But here with the graph, if we remember it's the area under the curve, that's the easiest way to go.